Welcome to Thailand.com.ai. AI exploring how tech and daily life tie with Dave on this adventurous quest. Welcome to Thailand.com.ai, bringing you the best. Welcome to Thailand.com.ai, where innovation meets the sky. Dave's your guide in this tech-savvy ride. Thailand.com.ai, let's see what we can apply.
Sawadee Cup, g'day and welcome back to the channel. Hope you are all well. In this episode I shall be talking about what people keep asking me, which is basically, can I keep explaining what AI works and how it is and what it does and all the rest of it. So I actually last week mentioned there was a very good small video produced by the CSIRO, which is the Australian government, basically science organisation, and they're a very interesting government department that basically have their finger on the pulse of everything that's going on, and they've actually produced a really good video. So I think we might have a quick look at that. It explains things quite well, but also too, I think we need to take a step back and just look at the big revelations and where this is actually heading. So anyway, interesting points of view.
It's behind the scenes in our favorite apps, making breakthroughs in the lab and constantly in the news. Artificial intelligence is all around us. But how does it work? Let's shed some light on the world of AI. Artificial intelligence is an umbrella term that covers a wide range of systems that all work in slightly different ways. But many of the most widely known use mathematics to find patterns in data. These patterns are then used to make predictions. The most common forms of these AI systems use something called machine learning, where algorithms analyze data, arranging the patterns and features into models. You can think of models a bit like a map. Let's look at how a machine learning model might use an image of a koala. This image has millions of pixels. When we put this digital file through a machine learning model, these data points are processed via layers of multiplication and addition until patterns start to emerge for different features. You can think of these like islands. The more images we add, the more comprehensive the map becomes. Here on Koala Island, the west side of the island represents koalas with small ears, and the east, big ears. What's really mind-blowing is that ear size is only one feature, and to represent all of the different shapes, colors, moods, and compositions of koala images, we not only have to get 3D, but imagine thousands of dimensions. Maybe for now, let's keep it at just 2. Now, if we take this map that's been trained with millions of koala images and ask what an image might look like here, an AI system can generate a completely new image related to that location. This is called generative AI. Amazingly, this mapping process works for any data, whether it's text, images, sound, whatever can be described with numbers. When we train models with these different data types together, it's a bit like combining 2 maps. Here, we have a text-to-image model, trained using images and their text labels. These models can take on complex tasks, answer questions, write poems and music, and even generate videos from scratch. But fundamentally, what we're doing is giving computer systems a way of mapping information and making connections between patterns. It's maths, not magic. So while these outputs are very convincing, it's important to understand that they're only a prediction based on training data. If we go back to our text-to-image map, and imagine that our text map was trained using American examples instead of Australian, this prompt might give us a much different result. Sometimes this can lead to something called bias, where unfair or unbalanced outputs are generated that amplify inaccuracies or gaps in the data. Take planning a playlist, for example. If an AI was trained using only your listening history, it won't have the right data to generate a playlist that appeals to everyone. It's important to remember that human and artificial intelligence are different things. For example, humans can instinctively understand context and apply common sense, AI systems approach things differently. That's one of the reasons it's important to understand how AI systems work, to ask questions and decide when and how we want to use them. In the right hands, AI systems can be incredibly powerful tools, helping manage huge data sets, see patterns that humans can't see, and automate complicated processes. But it's up to all of us to ensure it's being pointed at the brightest future possible. To find out more, check out csiro.au/AI.
Yes, I think that video covers it quite well, actually. It presents well. And just for those of you who aren't Australian, a thong in Australia is a flip-flop, which we wear on our feet. We don't necessarily wear them the way the koala did. Okay, so just going on to that, another interesting thing that I try to explain to people when I'm talking about AI is how it actually came into play. Now, obviously, I'm not a scientist. I'm not a computer engineer, but the idea that it thinks like a human brain with a neural network, and that was the big surprise moment. I've seen lots of interviews with Ilya Sutskever, who was the chief scientist at OpenAI. He is actually a very interesting guy. There's an interview he did just before he left, which he just explains a little bit about how neural networks, surprise him. And so I thought I might actually show that as well, just to give people a little bit more understanding of the actual people that came up with this. And obviously it wasn't invented overnight. I mean, this research, like all research, builds on the previous research. So let's actually have a look at this video from Ilya Sutskever. And I love the 1970s look, it's very cool. But it covers scaling. Now, it's interesting because that's a lot of speculation now. As we build more compute, the more powerful it gets. And I can explain a little bit more about how important that is with another interview by Jensen Huang from NVIDIA, which has just overtaken Apple. It's now the second largest public company in the world. And basically they design computer chips for AI. So anyone who thinks that AI is a fad can throw away your Apple phone because you've just been overtaken by NVIDIA and Microsoft. So it will be very interesting to see. But anyway, let's have a look at what Ilya's got to say here.
How good is our understanding of scaling laws? Like, if we scale these models up, how confident are you in being able to predict capabilities of these particular models? How good is that science?
So that's a very good question. The answer is so-so.
I was hoping for a more definitive answer.
Well,
go for it.
So is a very definitive answer. It means we are not great, but we are not absolutely terrible either. But we are not great, definitely not great. So what the scaling law tells you, it's a relationship between the inputs that you put into the neural network and some kind of a simple to evaluate performance measure like your next word prediction accuracy. And that relationship is very strong. But what is challenging is that we don't really care about next word prediction. We care about it indirectly. We care about the other incidental benefits that we get out of it. So for example, you all know that if you predict the next word accurately enough, you get all kinds of interesting emergent properties. Those have been quite hard to predict, or at least I'll say I'm not aware of such work. And if anyone is looking for interesting research work problems to work on, that would be one. I will mention one example, something that we've done at OpenAI in our run-up to GPT-4, where we tried to do a scaling law for a more interesting task, which is predicting accuracy at solving coding problems. We were able to do that accurately, very accurately, and that's a pretty good thing, because this is a more tangible metric. It's an improvement over next word prediction accuracy as far as things that are relevant to us. So in other words, it's more relevant to us to know what the coding accuracy is going to be, ability to solve coding problems, compared to just ability to predict the next word. It still doesn't answer the really important question of, can you predict some emergent behavior that you haven't seen before?
Okay. speaking of these capabilities that are kind of emergent capabilities, which ones surprised you the most as these models scaled? What was the thing where you said, like, well, I'm kind of astonished these models can do this?
It's a very difficult question to answer because it's too easy to get used to where things are. So there definitely have been times when I was surprised, but you adapt so fast. It's kind of crazy. I think maybe the big surprise for me is, it may sound a little odd, probably to most people in this audience, but the big surprise for me is that neural networks work at all. Because when I was starting my work in this area, they didn't work. Or it was like, let's define what it means to work at all. It means they could work a little bit, but not really, not in any serious way, not in a way that anyone except for the most intense enthusiasts would care about. And so now we see, like those neural nets work, so I guess the artificial neuron really is at least somewhat related to the biological neuron. Or at least that basic assumption has been validated to some degree.
What about like an emergent property? Was there one that sticks out to you? Like, for example, I don't know, code generation, or did you, maybe it was different in your mind. Maybe you just once you saw like, hey, neural nets can work and they can scale. Yeah, of course, all these sort of properties will emerge because, at the limit point, we're building a human brain and humans know how to code and humans know how to reason about tasks and so on. Did you just expect all of that, or did...
I've definitely been surprised. And I'll mention why, because the human brain can do those things, it's true. But does it follow that our training process will produce something similar?
Exactly, yeah.
So it was definitely very amazing. I think, seeing the coding ability improve quickly, that was quite a sight to be seen. And for coding in particular, because it went from no one has ever seen a computer code anything at all ever. There was a little area of computer science called program synthesis, which maybe it was very niche, and it was very niche because they couldn't have any accomplishments. It was they had a very difficult experience. And then these neural nets came in and said, oh yeah, code synthesis, like we're gonna accomplish what you were hoping to achieve one day, like tomorrow. So that was, deep learning.
Yeah, so it's interesting now what Ilya Sutskever has to say about neural networks and how they're a bit of a surprise. But I suppose if we just try and get the concept of, they've created, like a human brain, a neural network. And they're talking about scaling. So scaling is interesting. So more compute means better and closer to supposed AGI. And it's interesting the definition that he gives for AGI, because people have a different opinion about, what is AGI. And probably the best definition I've heard is AGI is literally like a computer, an AI, that is as competent as a work colleague. So that is AGI. So you could actually have a discussion with as I've done with Pi in the past, with your colleague that happens to be an AI. And when you think of it, I've done a lot of business over the years, and I've talked to people that I've known very, very well and never met them. So they could be AI, who knows? Maybe the whole world's AI. But you sort of can see what I mean. So that is what they're talking about, or that's his definition of AGI. And then super intelligence is something completely, it's beyond the realms of what humans can even comprehend. So I personally think AGI is not that far away, where we will have colleagues that will be AGIs. And like the example I've just given, like if I've had someone I've worked with for many years and I phone them up and I have a conversation with them, I've never met them, we action things, we get things done, we ask them different ideas and get things happening. So that could just as well be an AGI or an AI. Anyway, speaking of scaling, the man of the moment is Jensen Huang, who obviously started NVIDIA, and he's been doing all sorts of interesting talks. So I'd like to have a little look at this. He actually explains it quite well, particularly about the shift. Now, again, it's funny, my last video, there is pushback from people with AI, when you talk to them. And some of the people have just said, oh yeah, no, it won't, it might be all right, but it's not going away. You know what I mean? People are going to have to spend money on AI in their business, whether they like it or not. They will be forced to do it, because my thesis, my idea is that when a chip company that is particularly designed for building chips for AI, that has forward orders from Microsoft and Google and Apple and everybody else, is now, the second largest company on the planet, it ain't going nowhere. There's a lot of infrastructure still to go in. There's going to be some massive improvements and some massive changes. So hopefully, by watching crazy people like me talk about AI, you will at least have some idea in the early part of what's going on. And so let's have a quick look at what Jensen's got to say. I actually am right into weather, big time. I've always been into weather ever since I was a fire captain for the New South Wales Rural Fire Service. I spent my entire life looking at weather and did some advanced weather stuff. So weather modelling and having meetings with the Bureau of Met, which is the Bureau of Meteorology in Australia. I do remember, probably 15 years ago, going to a conference where the modelling that is used to predict weather from all sorts of data inputs, from planes in the sky to automatic weather stations all over the place, it was really who could get the best computer, and the BOM had the best computer to be able to run the best computer models. And I do remember them saying that the 7-day forecast, right, is as good as a 3-day forecast, and the 3-day forecast is as good as a 1-day forecast. So this is going back, like I said, about 15 years. So now with the compute and what they're talking about by building replicas of the world, of the Earth, to model weather, I find fascinating. So I've left that little bit in, but it's mainly the bit I wanted to show was how AI sits in the scheme of things.
Demo, right? It didn't take long. This is Earth 2. The idea that we would create a digital twin of the Earth, that we would go and simulate the Earth so that we could predict the future of our planet to better avert disasters, or better understand the impact of climate change so that we can adapt better, so that we can change our habits now. This digital twin of Earth is probably one of the most ambitious projects that the world's ever undertaken, and we're taking large steps every single year, and I'll show you results every single year, but this year we made some great breakthroughs. Let's take a look.
Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on Taiwan.
Someday, in the near future, we will have continuous weather prediction at every square kilometer on the planet. You will always know what the climate's going to be. You will always know. And this will run continuously because we've trained the AI, and the AI requires so little energy. In the late 1890s,
this is the bit that's interesting about
Nikola
the new
Tesla
industrial
invented
revolution.
An AC generator. We invented an AI generator. The AC generator generated electrons. NVIDIA's AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution.
Okay, so I won't go into that too much, but the point he's making is it is the new industrial revolution, and tokens, if we go back to the first video that the CSIRO talked about, are basically the new way of talking and transmitting information. So everything is tokenized, So it will be interesting to see where it all actually ends up. So I think I'll leave it there. Lots of people ask me just about, can we show your studio setup? So I'll add a little bit to that. And I'll leave it for the moment. And I'll catch up with you guys again in the next episode. Thanks for spending your time with me, and I'll see you again. Okay, well, here I am in the actual studio that I've got set up here for Thailand.com today. It's a pretty basic studio, but it does the job. It's not too bad. I've got my background stuff there and a couple of screens and a bit of lighting, so yeah, no, it actually works quite well. A couple of people asked me about it, so I thought I'd just do a quick video on that as well. Anyway, it's all good. I'll get back to work and better make a video.
So hit that subscribe